Hi everyone, welcome back to my channel. I am Dr. Shabazz here. So in this video, we will perform Friedman test in R. Friedman test is a non-parametric test used to compare three or more related measurements or repeated observations. It is useful when repeated measures ANOVA assumptions, especially normality, are not satisfied. Then we apply Friedman test because our data is not normal. So in this video, we will perform the Friedman test in R and interpret its results. If the p-value is less than 0.05, it indicates a significant difference among the repeated measurements. So if you like my video, please subscribe to my channel and press the bell icon so you can get my next video easily. So before performing the analysis Friedman test in R, we need to consult our PowerPoint presentation to see the criteria, threshold values, and methods. So we are going to do Friedman test in R. We are comparing three or more related measurements using within participant ranks. We do the same as ANOVA with repeated measures, but our data is not normal, so we are going to do Friedman test in R. This is basically a non-parametric test alternative to one-way repeated measures ANOVA. So the Friedman test compares three or more related conditions. So our research context is, did students' satisfaction ratings change across three stages of a training program or not? So we will measure this question. Why use this test? The same students provide ordinal ratings at all three stages and normality or repeated scores is not assumed. So it means all data and observations are related with each other. So in this way we apply Friedman test. So research question, the hypothesis we develop. Research question, do satisfaction ratings differ across before, mid-training and after training stages? So we create the hypothesis that the three related conditions have the same distribution and each alternative H1 at least one condition differs from others. So we have a data set of 12 students where we see the satisfaction score before training, mid-training and after training. So we also see the assumptions and rank-based interpretation. We will see assumptions to perform the Friedman testing are there are three or more related conditions, same participants measured in every conditions. Participants are independent of each other. Outcome is ordinal or continuous. Scores can be ranked within participants. And practical cautions, ties receive average ranks, report medians and IQRS. Significant chi-square doesn't identify condition pairs. Use adjusted paired Wilcoxon test after the omnibus test. Statistical significance is not effect size. So in this way, we'll see the thresholds and effect size. In case of testing the repeated condition distribution differ from another, we will see the p-value should be equal or greater than 0.05. In case of evidence that at least one repeated condition differs from others, so we will see the p-value should be less than 0.05. And we will apply the Kendall W power to see the effect size. Its value should be 0.10 or greater. So it means small agreement or condition effect. Kendall power formula, if the value is 0.30 and 0.50, so there is a moderate or strong effect. Interpret accordingly we will when we have a results in our according to our data set. So now we come back to our RStudio and we are going to import data in R. So I give data to ChatGPT and required coding. So first of all, we will import our dataset in R. So we copy this prompt and paste there and then press enter. So a dialog box will open and then you will select your dataset and then click open. So dataset has been successfully opened in our RStudio. So you can see the dataset. Next, we will apply the descriptive statistics and frequencies on our data. Copy this prompt and then paste it. Okay, so we get the results. You can see the satisfaction score before training is 2.75 and the median is 3. You can also see the standard deviation, minimum, maximum values and I. So you can observe the mean before training because there is a satisfaction mean score is 2.75, which is increased in mid training 3.41 tetra 67, and again the satisfaction score is increased further after training, which is 4.166667. So it means there is a significant change from before training to mid training and mid training to after training, and you can also see the before training to after training. Okay, so you can also see the frequency before, variable frequency. Okay, so next we apply the Friedman test plus post-hoc test comparison and effect size. We copy this prompt and paste in R and then press enter. So we get the results. You can see the Friedman rank sum test is chi-square value is 20.537 where the degree of freedom is 2 and the p-value is less than 0.05. So it means there is a significant difference because the value is less than 0.05. And you can also see the Kendall W power value is 0.855. So it means the value is higher than 5.5. So it means there is a strong effect, there is a strong change between the groups. Also we see that according to pairwise comparison using Wilcoxon signed rank test with continuity correction. So you can see before, after and before. So there is a change before and after. You can see diagonal. You can see before and after change, and then mid and after change, and before and mid change 0.0067. So p-value adjustment method we use HOM. Next, we save all test of Friedman results and put in one Excel file. So we need to copy and paste the prompt here and then press enter. So R successfully created the separate Excel file for all results. You can see, and you can find the file in the same directory. You can see here. These are the results of Friedman test. You can see the descriptive statistics and frequencies before, frequencies, mid frequencies and after training frequencies. And Friedman test results, there is a Kendall W value is 0.85, which is greater than 0.5. So there is a large change, large effect. And the p-value is less than 0.05. So there is also post-hoc comparison before, after, mid, after and mid before. We just interpret it in R. You can see all values according to HOM, all values are lower than 0.05. So there is a significant change between before and after, and there is also significant change between mid and after, and there is also a significant change of satisfaction score between mid and before. So in this way we do the Friedman test in R. So please subscribe to my channel and press the bell icon so you can get my next video on R data analysis.